Today we're going to look at finding limits algebraically. That is, we're going to look at finding limits without using a table or a graph. In a previous video, we went through and we had these equations and we used the tables to evaluate their limits by seeing what your y value approached as your x value approached a particular number, so 2 or -5 or 0. And then I asked, how else do you think we could have found the above limits without using the table? So hopefully after viewing the equation that you were given and the x value that you were approaching for each of these problems, you figured out, hey, instead of having to test a bunch of numbers, the one thing I could have done is just plug in each of these numbers, and that would have gotten me my limits. So the limit of 3x plus 5 as x approaches 2 is 11, because when I plug 2 into my equation, I get out 11. Same thing when I plug in -5 or 0 or 8 here, you just got out what your actual numbers were. And so when we start formalizing our steps for evaluating limits, that's always going to be the first one. So the very first thing you should be trying to do if you're determining this limit is you're just going to try to take whatever value x is approaching and plug it into your equation. So let's go ahead and do some of these examples here. So in this first one, it's the limit of this quadratic equation as x approaches -2. So the first thing I'm going to try is just plugging in that -2. Please make sure that you are using your parentheses correctly. We always joke that calculus ends up being the easy part of AP Calc, and algebra or arithmetic is the hard part. So -2 squared is a +4, -4 times -2 is a +8, and then plus one more would end up giving me 13. So that would be the limit of that equation. Same thing we can do here, so I'm going to go ahead and just plug in -2 everywhere there is an x value up there. So 2 times -2 minus 6 over -2 minus 2 more. So I end up with -4 minus 6 more is -10. And then -2 minus 2 more is -4. Negatives cancel, and 10 over 4 in fact reduces to 5/2. So that's the limit of that rational function. All right, go ahead and down here, -2, do the same thing. Everywhere there is an x value, I'm just plugging in that -2. So -2 squared minus 2 times -2 minus 8 all over -2 squared plus 4. On the top here, I get +4 plus 4 more, so that total is 8 minus 8 would give me 0. And then on the bottom, I end up with -2 squared is +4 plus 4 gives me 8. But 0 divided by any number, except for 0. So 0 divided by 8 is in fact just 0, and that is good to go. So the limit of that rational expression is 0. This looks very similar, and you're going to see one difference that happens when we try to plug in -2 here. So on the top, we have exactly the same equation. So I have -2 squared minus 2 times -2 minus 8. That ends up getting me a 0 on the top, just like it did in our previous example. But now on the bottom, I have 4 minus 4, which gives me 0 over 0. Now, 0 divided by 8 is a perfectly fine number. But when you divide by 0, this is what we call an indeterminate form, and it basically ends up in an error or an undefined function or something along the lines of that. And so if you're evaluating a limit and we run into this problem, just plugging in A won't be enough. We have to try some different strategies. So let's go ahead and we'll try our next strategy. Factoring, or one out, as another way of putting it, is another way to deal with these types of limits. So I like to refer to, if you're plugging in a value and it gives you 0 over 0, I often refer to that as it makes our universe explode. So if you hear me use that phrase, that's what I'm talking about. It's causing a disruption in our mathematical minds. So if that happens, we can try some algebraic manipulation, and the first and easiest type of algebraic manipulation we're going to learn is factoring or one-outing. So it's always a good idea to start here. After the function is simplified, then we're going to go back and try to just plug in the number again. Big important point. I think I'm even going to highlight it because this is just, I can't emphasize this enough. This is something we are only allowed to do for limits. You can't do this if if it's only a function, it has to have a limit in front of it. So don't try to go randomly applying this to the rest of math or anything of the sorts, because it only works for limits. So, for example, the first thing you always want to try, of course, is to plug in the value that x approaches. So the first thing, if I try to plug it in, I'll get 2, and it's just a little test over here. 2 times 2 minus 4 over 2 minus 2. Okay, we got 0 over 0, check. So now the thing that I'm going to try is I'm going to try to factor. So on top, I can factor out a GCF of 2. So there's a 2 inside the 2x and then 2 inside the 4. So I can pull that 2 out, and I'm left with an x minus 2. And then I still have that x minus 2 on the bottom. And the fun part about this now is that I can go ahead and factor or cancel 1 out is another way of putting them, both of those factors. And so then my final answer for that equation would just be 2. Now you can go ahead and you can try to plug in again, but there's nothing to plug into here, so the answer to this limit is just 2. But that would only work if you knew this strategy, and that was that you were able to factor or 1 out this term. Let's go ahead and we'll try this next example. So of course the first thing we always try is to actually just plug in 2. So we do 2 squared plus 4 times 2 minus 12 over 2 squared minus 2 times 2. So then I end up with 0 over 0 still, because you got 4 plus 8, which is 12, minus 12, which is 0. And then down here you have 4 minus 4. Okay, so now I know I can try to factor here instead. On top, it's what multiplies to negative 12 and adds to a positive 4. So that means we'll end up with an x, I believe an x plus 6 and an x minus 2. 6 and negative 2 multiply to negative 12, and 6 minus 2 adds to a 4. And then on the bottom, I have a GCF of just an x. Both of these terms have an x in them, so I can pull an x out front. I have an x minus 2 left over. And so then again, now I have these factors that I can get rid of that will allow me to now go back and try to plug in this limit. So now if I, down here, I have an x plus 6. Here, let's right over here. So now I'm finding the limit as x approaches 2 of just x plus 6 over x, which if I just plug in 2 on the top and 2 on the bottom now, 2 plus 6 is 8, and 2 on the bottom is 8 over 2, so the whole thing is 4. And again, this only works because I was able to factor out those x minus 2's. All right, let's look at these examples down here. So in this problem, again, the first thing you're going to want to do is you're going to go ahead and you're going to plug in a negative 2 on the top and a negative 2 on the bottom. Please do not forget to do these, because you're going to kick yourselves in the butt if you try to overcomplicate a limit. Let's see. So I get 0 on top, and on the bottom I got 4 minus 22, so that's negative 18 plus 18, so you get 0. And then I have to factor. Now this x squared minus 4 is a little bit tricky. You have to remember one of your special factoring rules, and that's your difference of squares. We're going to write 2 of them down here. But basically it's saying if you have a squared minus b squared, that's the same thing as a plus b and a minus b. This is called the difference of squares formula. And so in this scenario, our a would be x and our b would be 2, because 2 squared would give me a 4. So if I was going to factor that, I would end up with an x plus 2 on top, right next to an x minus 2. So that's how that part factors. On the bottom, though, we end up with what multiplies to 18 and adds to 11. Well, that's just a 9 and a 2. So x plus 9 and x plus 2. Now we see if there are any factors that we can cancel or 1 out, and there are. It's okay. They don't have to be right on top of each other. It also didn't matter which order you wrote these in. Excuse me. And so now when I'm finding this limit, secretly what I'm actually doing is I'm finding the limit as x approaches negative 2 of x minus 2, because that's the only factor that's left on top, over x plus 9. And if I plug in negative 2 on top, I get negative 4. And if I plug in negative 2 on the bottom, I get 7. So my answer would be negative 4 over 7. It's not as pretty of an answer as 4 or 2, but it still works. And then last but not least, let's go ahead and find this limit. So I have, first thing we're going to do is try to plug it in. 1 squared minus 2 times 1 plus 1 all over 1 cubed minus 1. So on top, I get 1 minus 2 is negative 1 plus 1, which is 0. And on the bottom, I get 1 minus 1, which is 0. Good. So I can go ahead and factor. On top, I can factor pretty easily what multiplies to 1 and adds to negative 2. Well, that would just work if I just had 2 minus 1s. So x minus 1 and x minus 1 on top. And then on the bottom, this one you might not have seen for a while, and even if you saw it a while ago, you might have forgotten it. This is when you have, over here we have the difference of squares, here we have the difference of cubes. So the difference of cubes, other factoring rule is if you have a cubed minus b cubed, you end up with a minus b, a squared plus ab minus b squared. And in this scenario, it'll be pretty easy because our a value is x because it matches, and then b cubed is 1, so b has to be 1. And so when I factor on the bottom here, it'll be x minus 1. And left over, I'll have x squared plus 1x minus 1 squared, which is just 1. And then we check and see if there's anything we can factor and cancel out. 1 out, and I can right there. And so then now we try again. So now when I find this limit, I'm actually going to write it down here. Woohoo. We're going to find the limit as x approaches 1 of x minus 1 over x squared plus x minus 1. 1 minus 1 on top is 0, and 1 plus 1 on the bottom is 2, minus 1 is 1. But really overall, that's just 0. Definitely make sure that you have these guys written down. We're going to use them much more often than just today, so make sure those are written down somewhere and maybe start committing them to memory a little bit. All right, we're going to go ahead and pause here. Let me know if you have any questions.